Alright, so today we're going to be going over limits and derivatives. So for this chapter, there are some few things to note before we start answering the questions. So a limit of a function fx, if you want to find the limit at 5, it's the limit from both sides. And for limit of function x, as x reaches 5 plus, that means as the function is reaching from the right side, what is the limit? For this, as it's both sides. Like in this case, it would be no answer. Undefined, or no answer. And for limit as function x goes to 5 minus, that means from the left side. So always remember, plus is from the right side, minus is from the left side. And also a horizontal asymptote. A horizontal asymptote is when as x goes to infinity, the y value goes to a y, like a value, like let's say 2. The horizontal asymptote of the equation was 2. So the graph gets ever so close to 2, but it never actually gets to 2. And same thing with the vertical asymptote. Let's say this is 2. This equation gets ever so close to 2, but it never actually touches 2. So as the limit goes, as x goes to 2, the limit is infinity for this. And infinite limits, this so let's say limit as x goes to infinity. For this graph, as x goes to infinity, the limit would be infinity, and as x goes to negative infinity, the limit would be negative infinity. So that's just these are just the main things to know in this section, and let's get started on with the questions. Alright, so let's start on with number 1. Explain in your own words what it's meant by the equation limit as x goes to 2 if x equals 5. So this basically means that let's say 1, 2, 3, 4, 5. So basically from the left side, as the graph comes from the left side and the right side, the graph at x equals 2, it reaches 5. So it's basically the coordinate point from the left and the right side. This limit is talking about the left and the right side. It reaches 2 coordinate 5. So is it possible for this statement to be true yet f2 equals 3? Now this could be true. So let's say we have 1, 2, 3, 4, 5. Let's say we have an open circle. So you'll learn this later on. This is a removable discontinuity. So basically, as the limit of x goes to 2, it's still 5, but the point of f2 could be at 3. It's still like allowed in math. So this would be a removable discontinuity, but the limit as x goes to 2 would still exist, because it's reaching the same number from both sides, although f2 might not be the same. So let's go to number 2. Explain what it means to say that limit as x goes to 1 minus function equals fx3. So what this is basically saying is that as x reaches 1 from the left side, the graph hits y equals 3. So the function could look something like this. Even if from the right side it's not 3, this function would still be true. So let's go on to this now. As limit x goes to 1 from the right side, the function equals 7. So this is basically just the opposite. Let's say a 7, and from here 1. Let's say from the right side, this is referring to the fact that the graph is going to hit y equals 7 from the right side. Now the left side doesn't matter here. It doesn't matter if it's not continuous or removable discontinuity, but this function will hold true as long as the limit of the line from the right side hits 7, or as it's approaching 7 from the right side. So in this situation, is it possible that the limit of 1 exists? So in this situation, since from the left and the right side, since they're not reaching the same number, they're not approaching the same number, because 3 and 7 are two different numbers. Since they're not approaching the same number, the graph would look something like, from the right side reaches 7, left side reaches 3. That's not a continuous graph, that's a broken line. So in that case, the limit at x goes to 1, it wouldn't exist. It wouldn't even be like a removable discontinuity, nothing. The limit wouldn't exist because it's hit from both sides. It's approaching two different numbers. So let's move on to the next question. Use the given graph of f to state the value of each quantity if it exists. If it does not exist, explain why. So this is the graph we have to base our answers off of. So limit as x goes to 2 from the left side. So this is 2 as it goes from the left side. It's hitting 3. So it's reaching 3 from the left side. So the answer for that would be 3. So limit as x goes to 2 from the right side. From the right side, as x goes to 2, it reaches 1. The answer of that would just be 1. So the limit as x goes to 2 of the function, now remember here how as x goes to 2 from both sides, they're reaching two different numbers, 3 and 1, which would mean that the limit does not exist. And so D, F2. So we're looking for the filled in circle here. So at x equals 2, F2 would be 3 because this circle is filled in, this one is hollow. That means the point is 3. So that means F2 is 2, 3. That's the coordinate. So the answer to that would just be 3. So E is limit as x goes to 4 of the function. So as x reaches 4, from both sides, they're both reaching 4, the y value of 4. So this is a removable discontinuity, as we talked about, because of the hollow circle, or the point rather. So f is, what is the y value at x equals 4? So since this point is hollow and there's no point along what we can see, this would just be does not exist, because we aren't given substantial information to prove the y value of this at x equals 4. We know the limit, but since the removable discontinuity, we don't know the y value. Alright, so for this question, let's see, for the function g whose graph is shown, find a number a that satisfies the given description. So basically we have to look at these criteria and then find a point here or a limit that follows all the criteria. So for a, limit as x goes to a, g does not exist, but it is defined. So we need to look for a limit that does not exist, as in it's a broken line, but the limit is defined. So for this we could, there's only one answer here. At x equals 4, you could see that g4 is defined because there's a filled in point here. So g4 is y equals like 2.1 or 2.2 rather, but the limit does not exist because it's a broken line. So the x value that a would be, or rather a is equal to 4 for this first question. Our second was limit as x goes to a, g exists. but it is not defined. GA is not defined. So for this, this is just explaining a removable discontinuity with no like real point on the y-axis. So for this, this at x equals 5 seems just right, where there's no actual coordinate point along G5, but the limit exists since from the left and the right side they're both reaching 1.7. So for this we would put a is equal to 5. So for C, as limit x goes to a from the left side and limit as x goes to a from the right side both exist, but the limit x to a does not exist. This is talking about that the limit itself, it's a broken line, but from the left and the right side they're both reaching a number, which it could just be this right here. From the left side it's reaching 2.7 ish, and from the right side it's reaching 1.8. So which means since it's reaching two different numbers from both sides, the limit does not exist. So here the a would be equals to 2, the x value of 2. And for D, as limit x goes to a from the right side equals GA, but limit as a goes from the left side does not equal GA. So for this we could just put what we did for the other question. So as a goes from the right side on let's look at x equals 4. So as a goes from the right side, it reaches the y coordinate of 2.1, which is also equal to G4 because it has a filled in point. But as a goes from the left side, the limit does not exist and it doesn't reach 2.1. It reaches 0.6. So for this, a would be equals to 4. It has very similar criteria to a. Both of them are the same answers too. Alright, let's do some questions on our own. So you can pause the video now and complete question 3. Alright, so for question 3, it is explain the meaning of each of the following. So as the limit, let's draw a graph so we can visualize it. As the limit of x goes to -3, fx goes to infinity. So that would look something like this. It would be a vertical asymptote. So the limit from both sides, as it goes to -3, it reaches infinity. The meaning of that is what I just said. As the x coordinate reaches -3 in the function, the y value goes to infinity. And for B, let's draw another graph to visualize it. So as x goes to 4 from the right side, so only from the right side, fx goes to -infinity, which could look something like this. It would be you could make it a vertical asymptote. You could also make it something like this or something like this. It doesn't matter. Anything that happens on the left side in this equation doesn't matter because we're only talking about the right side because of that plus. So as it reaches 4, the x value from the right side, the y value dips to -infinity. So that would be, you could make that, it would be a vertical asymptote if it is from the left side as well. Alright, now I want you guys to try this question out, number 5, so you could pause the video and try it out. Alright, so number 5 is asking us, for the function f whose graph is given, state the value of each quantity if it exists. If it does not exist, explain why. So for this, we just have to give a numerical quantity like a y value for all of these. So let's set it up real quick. So let's take a look at the graph. Limit as x goes to 1 of the function. So as x goes to x equals 1, the limit from both sides, it's 2. It's reaching 2. The answer this would be 2. So for b, as limit x goes to 3 from the left side. So from the left side, x equals 3 is over here. So as x reaches 3 from the left side, it reaches y equals 1. So the answer of this would be 1. So as the limit for c, the limit as x reaches 3 from the right side. Now from the right side, as x reaches 3, it equals 4. So this would be 4. So the limit as x goes to 3 of the function. Now the limit does not exist because from the right and the left side, they're both reaching two totally different numbers. So in this case, that would be does not exist. And for the last one, we need to find the y value when x equals 3, f3. So that would just be this point right here. So at x equals 3, the y value is equal to 3. So the coordinate of this would just be 3, 3. So the answer of this is 3. Alright, let's do one final question here. So you guys can pause the video and complete this. Alright, so number 8 is telling us for the function a whose graph is shown, state the following. So this is similar to the equation before, except now we're dealing with some vertical asymptotes, no horizontal asymptotes yet. And alright, so a is asking us limit as x goes to -3. So -3 is right here. So the limit we can see from the left and the right side, it's reaching infinity. So the answer of this would be infinity. So b is asking us limit as x goes to 2 from the left side. So as x reaches 2 from the left side, we could see that this graph is going towards negative infinity. So the answer of this would be negative infinity. And the third one is asking us limit as x goes to 2 from the right side. So we could see as x goes to 2 from the right side is going to infinity. So this would just be the opposite of the other one. It would be infinity. And D is asking us the limit of x as it goes to -1. So -1 is right here. So we could see from the left and the right side it is going to negative infinity. So that would be your answer. So and now E is asking us the equations of the vertical asymptotes. So we have to find at what x values that there is vertical asymptotes. So let's start marking down the vertical asymptotes here. There's one over here at -3. So let's jot down -3. And then there's one at -1. They're both reaching negative infinity. -1. And finally there's one at 2. I know they're both reaching, this is from the right side it's going to infinity, from the left side it's going to negative infinity, but since the equation never reaches 2, this x equals 2 will also be a vertical asymptote, and there's nothing else. As x goes to infinity, the limit of this would just be infinity, because as we don't have substantial information to conclude anything over here. So for E, this would just be the answer. Alright, so I hope you guys understood limits and derivatives and what is a limit, as well as how to find the limit, as and also what they're asking you. Always from the negative means they want the limit from the left side, positive is from the right side, infinities, and then just when to know when a limit does not exist as well. And yeah, that's basically it.